Hi everyone. So today we're going to go over 11.3, the tangent line equation, and we talked about it in the last class as a little preview about finding the equation of that tangent line. Remember that the difference quotient meant was a way to find the slope of that line. So I'm just going to give another introduction here, 11.3, tangent line. Where when you were given this graph, we were saying that we want our h value, which is the distance between those 2 points, to be very, very close to 0, right? So as this point gets closer and closer, remember it kind of looked more like the tangent line, which is what we want it to have. But it can't equal 0, but it could get really, really close to the 0. Now, if we wanted to find the slope of that line, we're going to be able to use that by your algebra, right? So to find a slope between 2 points, you would take your y values, in this case is f of x plus h, and you subtract the y value of the other point, and it's all divided by the x values. So if we were to simplify that even more, the top will stay the same, and on the bottom, the x's would cancel out and you would just get h. So that's your difference quotient. So that's how the difference quotient came about, in order to say that that's the slope of that tangent line. Now, remember that it was actually a secant line because these are the slope between 2 coordinate points. But if we wrote down the limit as h approaches 0 in front of it, then that makes it more like a tangent line equation. Okay? So this is known as the limit process. So if it says to find the derivative using the limit process, it means to have the limit as h approaches 0 of that difference quotient. So we're just going to do another example to find the slope. So it's going to say find slope of a given function, and these are all about curves, right, at a certain coordinate point. So at the point -1 and 2. Now, our -1, because this is our point of tangency, that's going to be our x, and our y value is our f of x. So when we set it up to find the slope, we have m equals the limit as h approaches 0. Our x value that we're given is -1, so we'll be able to plug that -1 directly into our x. Okay, so we have -1 plus h minus f of x. So f of -1 all over h. We're just going to calculate it now. So remember, finding f of -1 plus h means that you're plugging -1 plus h in for your x's. So we have -1 plus h cubed plus 3. Then I'm going to take, again, in a different color, f of -1. We'll be subtracting, plugging in -1 into our function, all over h. Simplifying it more. Okay. So we could expand the cubic using our Pascal's triangle, if you remember that, where it begins with the 1, and then it has a 1, 3, 3, 1. So these are going to be my coefficients. And then the first term starts with the 3 and decreases by 1 each time. And then the second term, the h, starts with 0 and increases each time. So this would be the setup. To the third power, it's your coefficient times h, another coefficient, until the last one. So this is our expansion of the -1 plus h to the third power using the Pascal's triangle. And then we're going to subtract it from the value that we get from the negative 1 cubed plus 3, which is 2. And it is all over h. So remember, our goal is to make sure as we're simplifying that all of the terms will cancel out, and you'll be able to factor an h out so that it cancels with the h on the bottom. Okay. So when we simplify it, I get negative 1 plus 3h minus 3h squared plus h cubed plus 1. Oh, I forgot the plus 3. Sorry. And then minus 2. Okay. So I forgot this plus 3 right here to bring it back down. And then it's all over your h. So the 1s are going to cancel. And I'm able to take an h out of all the other terms. So these will cancel. Right, so remember that's where our whole is located. So we really now have the limit as h approaches 0 of our simplified equation. And then now we could plug in our h to be 0, so we have 3. Okay. So we're saying that my slope is 3 at the coordinate point negative 1, 2. And if it asks for the actual equation of the line, then that's when you would be using your point slope. The y minus y1 equals m times x minus x1. Okay. Now, in calculus, it's very tedious to keep plugging in these values, like the x value, into your equation and then start solving for it. Because sometimes they're going to ask you to find it for multiple coordinate points. So we're going to be able to find a formula to find the slope at any point. So we want to be able to find a general formula so that if you're given multiple points, you could just use that equation and then plug in those different x values. So an example, if our function is x squared minus 4x, we're going to use the general difference quotient. So there's no x value that you're given here yet. So you can have m equals limit, h approaches 0 of our difference quotients. So we have equals limit. So make sure that the equal sign is on the left side of the limit, because you're going to have to write limit each time. Okay? And then the equal sign just follows all the way down. So we're going to plug in x plus h into wherever we see an x, and we see it 2 times. And then we're subtracting our f of x, which is the entire x squared minus 4x. So we need to put that in parentheses or in brackets, all over h. Do your algebra, simplifying. So we have x squared 2xh plus h squared. Distribute the negative 4, and then distribute the negative into that function. Okay. We're almost there. It gets very long. So we could see that the x squares are going to cancel, and the 4x is going to cancel. So all the terms that are left have an h in there, which is again what we want to take that out. So remember, you need to show that. And you just write it in the order of whatever's left over. Those cancel. So the last line will be the limit of our simplified. Always have the simplified equation there. And then you could plug in the h to be 0 and just put equals. So that would be 2x minus 4. So we're saying our slope is 2x minus 4 at any point. So that means that we could find the slope at any coordinate point along the curve of the x squared minus 4x. So if I wanted to find the slopes at, let's say, 2, -4, and at -1, 5. So for the 2, -4, because my x value is a 2, that's what we're going to be plugging in to get what our slope is. Because this is a general formula to find our slope for that equation. So my slope there is 0. So we'll say my slope is 0 at the point 2, -4. So that means there's a horizontal line at that point. To find it at -1, 5, we're going to do the same thing. Use the same slope formula that we had, or that we found. And so that equals -6. So we're saying my slope is -6 at the point -1, 5. So you see, it's a lot easier to do the general to find it for different slope values than to plug in the 2, do the whole thing, and then second question, plug in the -1 and do the whole thing. So we're always going to try to do the general first, and then plug in the point values that are needed to find each of those slopes. So all of this, your slope means derivative. Okay? A big, big term in calculus. Okay? Now the notation that we're going to be using, because now we're graduating from the m, we're not going to use m for slope anymore. The notation that we're going to be using is f prime of x. So I'm going to write that, f prime of x. So it looks like it's to the first power, but it's really like an apostrophe. Right? So that stands for the derivative. So instead of saying m equals that limit, we're going to say the derivative is equal to the limit of our difference quotients. So this is the notation that we're going to be using from now on, is the f prime of x. Okay, so we're going to just do one last example, and then we should be good to go. Let me just get paper here. So instead of saying finding the slope, we're going to use now the calculus term, okay? It's going to say find the derivative of the function. Okay, sounds more calculus-y, right? To say derivative rather than slope. So our notation, f prime of x, right, equals the limit h approaches 0 of f of x plus h minus f of x all over h. Okay. So I want you to try that. You remember how to work it out already, and see if you get these answers. Okay. 4x minus 5. So this is your derivative. Part B, find derivative. Again, meaning find the slope. Find derivative at the point -3, 33. And see if you get -17. So this is saying the slope at -3 equals -17. And see if you could find the actual tangent line equation, which comes out to be -17x minus 18. Okay. If you have any questions, feel free to email me, but I'm hoping that you'll be able to work out the derivative to find each of those 3 answers. Thanks, guys. Have a great break.